Hello friends, welcome to Smart Thinkers Hub and welcome to our chemistry class today. We are going to look at balancing of chemical equations. It's a very important topic in chemistry. It is important to balance a chemical equation because it makes the equation to be in agreement with the conservation of matter, which is a fundamental principle in chemistry. Now recall from Dalton's atomic theory that atoms can neither be created nor destroyed, but can only be transformed from one form to the other, or from one form to another. Now, what it means is that if you have a chemical equation depicting a reaction, let's say sodium, an atom of sodium reacts with 2 atoms of chlorine to give sodium chloride, which is common salt. This principle is saying that this sodium will still, it can only be transformed, this metallic sodium can only be transformed to in form of sodium chloride, that this sodium can never be destroyed. The only thing is that it has only appeared in another form. So the reactants, the elements in the reactants, the mass of the elements in the reactants must be equal to the mass of the elements, the respective or individual elements in the product side. So if a chemical equation does not obey this law, it's not in accordance, that the mass of each of the elements, the amount of matter in each of the elements on the reacting part and the product side does not match, you have to balance it. You have to make it match. And that is the principle of balancing a chemical equation. And also recall that Dalton also said that when atoms combine, they do so in simple whole number ratios. So what does it mean? What it means is that the combination of these atoms, say sodium giving you this, is gonna be in simple whole number ratio. So you're not expected to put 0.1 or 0.03. No, you have to use whole numbers. So if we have that sodium, we have 1 atom of sodium here, or 1 molecule of sodium here, and here we also have 1 atom of sodium. At least sodium is balanced. But chlorine, we have 2 atoms and we only have 1 atom of sodium, of chlorine. So you are expected to balance the quantity of chlorine here, and you can only do that in simple whole number ratio. You are only expected to put whole numbers, let's say 1, 2, 3, 4, 5, 6, etc. These are whole numbers. So we can decide to balance this chlorine by putting a whole number here as a ratio of this particular one. So we can now say if here is 1, here is 2, so they are now in whole number ratio. Mind you, you are not expecting to alter the atom here by putting 2. It is not done that way. So let's take the first example. sodium plus. So now you have to identify the reactant parts, the reactants, and the products. So this is the reactants, this is the products. So now we have to state sodium, how many quantity of sodium do we have, chlorine, how many do we have, and the reactant parts. In the product we have sodium and chlorine. So sodium here, we only have one atom of sodium, so we have one. Chlorine is 2, we have 2. Sodium here is 1, chlorine is 1. To balance chlorine, we need to put 2 here. So putting 2 here now, chlorine becomes 2 because 2 times 1 here is 2, and chlorine is 2 here. So chlorine is balanced. But that has also affected sodium. In other words, to balance sodium, we put 2. Now if you check, sodium is 2. So in the second case now, sodium is 2, chlorine is 2. Here, sodium is 2, chlorine is also 2. So the equation is balanced. So to do this, we have sodium is 1, sulfur is 8, sodium is 2, sulfur is 1. So sodium is not balanced. To balance sodium, we put 2 here. So now sodium is balanced. So, but sulfur is not balanced. So we have to put 8 here. Sodium is 16. Sulfur is 8. Sodium is 16. Sulfur is 8. So the equation is balanced. K. So how do we balance it? We need to understand that here, first, K is 1. O is 1 plus 2, which is 3. H is 1. And C is 1 from the reactant part. Then if you go to the product, K is 2. C is 1, O is 3 plus 1, which is 4. Then you have H is 2. So to balance this, to balance K, we put 2. We put 2 here. So if we put 2 here, K becomes 2 and 2 here. So we go to oxygen. Oxygen, which is O, is 3 here. Oxygen is now 2 plus 2 here, which is 4. So we have oxygen is now 4. Then oxygen is 4 here, which is balanced. Then hydrogen, H, is no longer 1 here. H is now 2 because this 2 is multiplying every of the elements in this particular compound, KOH, potassium hydroxide. So we have H is now 2. And the H here is 2. This is balanced. Then our C is 1 and our C is 1 here. So everything is balanced.